Article 352.44 addresses expansion fittings for PVC conduit. However, its application is specifically limited to straight runs of conduit situated between securely mounted items. These items can include boxes, cabinets, elbows, or other conduit terminations where an expansion of 1/4 inch or greater is anticipated. Now let's consider the scenario involving a service entrance. The service entrance consists of a vertical run spanning 6 feet, incorporating two 90-degree bends, and terminating 2 feet above the second 90-degree bend with a weatherhead. The critical point here is that both elbows are oriented in the flat, meaning they are not inside or outside elbows in the conventional sense. In this specific situation, Article 352.44 does not apply because the conduit run is not a straight run. The inclusion of the two 90-degree bends fundamentally alters the configuration. Consequently, the requirement for expansion fittings is waived, and you are not obligated to incorporate them into the design. To elaborate further, expansion fittings are designed to accommodate the expansion and contraction of PVC conduit due to temperature variations. PVC has a relatively high coefficient of thermal expansion compared to metals. This means that its length can change significantly with temperature fluctuations. In straight runs, particularly long ones, this expansion and contraction can create substantial stress on the conduit and its supports, potentially leading to damage or failure. Expansion fittings are engineered to absorb these movements, preventing stress buildup. The NEC, or National Electrical Code, provides guidelines for electrical installations to ensure safety and proper functioning. Article 352 specifically covers PVC conduit, outlining the requirements for its installation, support, and use. Understanding the specific requirements of each section of Article 352 is crucial for compliant and safe electrical work. Now, let's delve deeper into the factors that influence the applicability of Article 352.44. Firstly, the term straight run is essential. It refers to a continuous section of conduit that runs in a single direction without any bends or offsets. Any change in direction, such as a 90-degree bend, disqualifies the section from being considered a straight run for the purposes of this article. Secondly, the phrase securely mounted items is also crucial. It implies that the conduit is firmly attached to fixed objects, such as boxes, cabinets, or structural elements of the building. These secure mounting points restrict the conduit's ability to move freely, making it more susceptible to stress from thermal expansion and contraction. Thirdly, the expectation of 1/4 inch or greater expansion is the threshold that triggers the requirement for expansion fittings. This expectation is typically based on calculations that take into account the length of the conduit run, the temperature range it is likely to experience, and the coefficient of thermal expansion of PVC. If the calculated expansion is less than 1/4 inch, expansion fittings are generally not required, even in straight runs. In the service entrance example described, the presence of the two 90-degree bends effectively negates the need for expansion fittings regardless of the expected expansion. The bends provide flexibility that allows the conduit to absorb thermal movement without creating excessive stress. The conduit can expand and contract slightly at the bends, relieving the pressure that would otherwise build up in a straight run. It is important to note that the interpretation of NEC articles can sometimes be complex, and it is always advisable to consult with a qualified electrical inspector or engineer if you have any doubts about the correct application of the code. Local jurisdictions may also have their own interpretations or amendments to the NEC, so it is essential to be aware of the specific requirements in your area. Furthermore, the NEC is updated periodically to reflect changes in technology and best practices. It is crucial to stay up to date with the latest edition of the code to ensure that your electrical installations are compliant and safe. While Article 352.44 does not apply to the described service entrance, there may be other applicable requirements in the NEC that need to be considered. For example, Article 350 covers flexible metal conduit, Article 348 addresses rigid metal conduit, and Article 344 pertains to intermediate metal conduit. Each of these articles has its own specific requirements for installation, support, and use. It is essential to select the appropriate type of conduit for the application and to follow all applicable code requirements. Additionally, the NEC contains general requirements that apply to all electrical installations, regardless of the type of conduit used. These requirements cover topics such as grounding, bonding, overcurrent protection, and wiring methods. A thorough understanding of the entire NEC is essential for safe and compliant electrical work. Now let's consider some additional scenarios to further illustrate the application of Article 352.44. Scenario 1 involves a long, straight run of PVC conduit installed on the exterior of a building in a climate with significant temperature variations. The conduit runs for 100 feet between two securely mounted electrical panels. In this case, the expected expansion of the PVC conduit would likely exceed 1/4 inch, and expansion fittings would be required to prevent stress on the conduit and the panels. Scenario 2 involves a short, straight run of PVC conduit installed indoors in a climate-controlled environment. The conduit runs for only 10 feet between two securely mounted junction boxes. In this case, the expected expansion of the PVC conduit would likely be less than 1/4 inch, and expansion fittings would not be required. Scenario 3 involves a run of PVC conduit that includes several offsets and bends. The conduit runs for 50 feet between two securely mounted pieces of equipment, but it includes 3 45-degree offsets and 2 90-degree bends. In this case, the presence of the offsets and bends would provide sufficient flexibility to absorb thermal movement, and expansion fittings would not be required, even if the expected expansion exceeds 1/4 inch. It is important to remember that the specific requirements for expansion fittings can vary depending on the application, the climate, and the local code requirements. Always consult with a qualified electrical inspector or engineer to ensure that your electrical installations are compliant and safe. In addition to expansion fittings, there are other types of fittings that are used with PVC conduit, such as couplings, connectors, elbows, and tees. Each of these fittings has its own specific purpose and must be installed in accordance with the NEC and the manufacturer's instructions. Couplings are used to join two sections of conduit together. Connectors are used to attach conduit to boxes, cabinets, or other equipment. Elbows are used to change the direction of a conduit run. Tees are used to create branches in a conduit run. When installing PVC conduit, it is important to use the correct type of fittings and to properly glue them together. The glue used for PVC conduit is a special type of adhesive that is designed to create a strong, watertight bond. It is important to follow the manufacturer's instructions carefully when gluing PVC conduit fittings. In addition to the physical installation of PVC conduit and fittings, it is also important to consider the electrical characteristics of the conduit. PVC conduit is a non-conductive material, which means that it does not conduct electricity. This makes it a safe choice for electrical installations, as it helps to prevent electrical shocks. However, it is important to properly ground the electrical system to ensure that any fault currents are safely diverted to ground. Grounding is the process of connecting the electrical system to the earth, which provides a low resistance path for fault currents to flow. This helps to prevent electrical shocks and fires. The NEC provides detailed requirements for grounding electrical systems. It is important to follow these requirements carefully to ensure that your electrical installation is safe and compliant. Now let's discuss some common mistakes to avoid when working with PVC conduit. One common mistake is using the wrong type of conduit for the application. PVC conduit is not suitable for all applications. For example, it should not be used in areas where it is exposed to high temperatures or corrosive chemicals. Another common mistake is failing to properly support the conduit. PVC conduit must be supported at regular intervals to prevent it from sagging or breaking. The NEC specifies the maximum spacing between conduit supports. Another common mistake is using the wrong type of fittings. It is important to use the correct type of fittings for the type of conduit being used and the application. Another common mistake is failing to properly glue the fittings together. This can lead to leaks and electrical problems. Another common mistake is not following the NEC requirements for grounding. This can create a safety hazard. To avoid these mistakes, it is important to carefully read and follow the NEC requirements and the manufacturer's instructions. It is also a good idea to consult with a qualified electrical inspector or engineer if you have any questions. Now let's move on to discussing some advanced topics related to PVC conduit. One advanced topic is the use of PVC-coated rigid metal conduit. PVC-coated rigid metal conduit is a type of conduit that combines the strength of rigid metal conduit with the corrosion resistance of PVC. It is often used in harsh environments where corrosion is a concern. Another advanced topic is the use of underground PVC conduit. Underground PVC conduit is a type of conduit that is designed to be buried underground. It is typically used for underground electrical services and for running electrical wires to buildings. When installing underground PVC conduit, it is important to follow the NEC requirements for burial depth and backfill. Another advanced topic is the use of large diameter PVC conduit. Large diameter PVC conduit is often used for underground duct banks and for other applications where a large number of electrical wires need to be run. When installing large diameter PVC conduit, it is important to use special tools and techniques to ensure that the conduit is properly supported and jointed. Another advanced topic is the use of special types of PVC conduit, such as Schedule 80 PVC conduit and fiberglass reinforced PVC conduit. Schedule 80 PVC conduit is a thicker wall type of PVC conduit that is stronger and more resistant to damage than Schedule 40 PVC conduit. Fiberglass reinforced PVC conduit is a type of PVC conduit that is reinforced with fiberglass for added strength and durability. These special types of PVC conduit are often used in demanding applications where extra strength and durability are required. In conclusion, understanding the nuances of NEC Article 352.44 is crucial for ensuring compliant and safe electrical installations involving PVC conduit. While the article specifically addresses expansion fittings in straight runs, it is important to consider the overall configuration of the conduit system and the potential for thermal expansion and contraction. By following the guidelines outlined in the NEC and consulting with qualified professionals when necessary, you can ensure that your electrical installations are both safe and reliable. The key takeaway is that bends in the conduit, such as the 90-degree bends described in the service entrance example, can provide sufficient flexibility to negate the need for expansion fittings, even when the expected expansion exceeds 1/4 inch. However, it is always essential to assess each situation individually and to consider all applicable code requirements. Remember to always prioritize safety and compliance when working with electrical systems.